Question 2 is on proofs, and with these you've just got to be careful, even if you sort of understand what to do, that you actually get it clearly written down on the page. So part 1 is asking us to show that that quadratic is always positive, is always greater than 0. You can do this through the discriminant. It takes a little bit more explaining, and you have to kind of sketch the graph to do it that way. So I'm going to do it by completing the square, because that's the slightly quicker way to do it. So you're going to get your first mark for completing the square on that quadratic. Okay, so that's really what I'm trying to prove. So how can I go about explaining that? Well, I can do it quite simply. If and I can either do this using inequalities, or I could put a statement. I could put this in words, but square number is always greater than or equal to 0. So therefore, if we're saying that it's x minus 4 squared plus 1, that's always greater than or equal to 1. So basically, we've shown it. We've shown, and you always want to write a concluding statement. So let's go back to the original thing we were trying to prove. And let's just really finish it off. So for all real values of x. Okay, so that's sort of the bare minimum of what you need to write. But as long as you have all of those points, like as I said, either written in as a statement or written using the inequalities, that's perfectly fine. Okay, and then so part 2. Now, again, this one is probably a bit simpler, but you do need to be sure that you've actually written down everything that they've asked for. So if I add 3 to a number and square the sum, the result is greater than the square of the original number. So a good idea is just to try a couple of values to get the ball rolling. So let's see, well, what happens if x is 1? Let me start nice and simple. So if I add 3 to a number and square the sum, so the result is greater than the square of the original number. So 4 squared is greater than 1 squared, so it is true. But obviously that's not proof that it's always true. To prove that it's always true, I'd have to do it algebraically. So let's have a think about whether I can start to spot about any instances where that wouldn't be true. So I can't see any reason why positive integers wouldn't follow the same pattern. So I might start to think about numbers with a magnitude less than 1, or negative numbers. So let's try a negative number. Let's try negative 5. So I'm going to try negative 5 because when I add 3 to it, it's still going to be a negative. Okay, there's no other real special reason why I've chosen that. So negative 5 at 3 squared, is that greater than negative 5 squared? So negative 5 plus 3 is negative 2, and negative 2 squared is 4. Negative 5 squared is 25, so that is not true. So that's all the working I need. If I've shown that for one example it's true, one example it's not true, I can conclude that it's sometimes true. Now, where you need to be careful is you must get that working written down. So you must get the working for showing that it's true and showing that it's not true in at least one case for each. And then you must also, even though it may seem obvious, conclude that you've actually shown it is sometimes true. So don't kind of assume that because you've shown that one time it works, one time it doesn't, that's enough. You must clearly state what it is you have shown for full marks.